Hello everybody, how's it going? This is going to be a little bit of a different tutorial video. Essentially, here at Piloto Studio VFX, I plan on making a lot more VFX-centric tutorials, and not just shader-centric tutorials. The reason why I've been sticking mostly to shaders, it's because I feel like there's not good resources out there, but also because VFX kind of requires shaders in order to be made, and I want to give a general primer on what shaders are before jumping into visual effects. However, for most of my VFX work, I usually use a pre-built shader that I've had for a couple of years now. This is the Piloto Studio Uber VFX shader. As such, this tutorial will cover everything this shader can do and how you can use it, because in future tutorials we will use this shader to make our VFX. So you might be wondering, how do I get these shaders? Well, it's very simple. You just go here on the Unity Asset Store and you search for Piloto Studio Shaders, and you're gonna find these shaders here. We're gonna be specifically covering the VFX shaders, which has all of the main features that you would need to make VFX. These other shaders here, while they're useful, they're not really relevant, and they're also far simpler. So let's jump into it. Remember, all of this is absolutely free. As an initial example, I'll use this dragon breath here as an example of the capabilities of the shader. So here we have the particle, and you can see that it has a lot of elements. So let's focus on each one of them individually. First, we have just a couple of sparks. These sparks are actually one of the simplest ways you can use the shader. So here we have a material, and it has the Piloto Uber Effects shader assigned to it. And you can see here, it's set to transparent. These surface options here, they don't matter as much. But you can see here that on the blend mode, it is set to 1. This is very important because this essentially assigns what your material is going to be, if it's going to be additive or if it's going to be alpha blended. So you can see here that at 1, it means it's additive. At 1 minus source alpha, it means it's going to be alpha blended. Keep in mind that you can play around with the other settings here, but in general, most of the time, you're either going to use 1 for additive materials or 1 minus source alpha for non-additive materials. And you can see here the kind of result that this is going to yield. So in this case, this is additive. You're going to see here that we have a couple of settings on our texture here. So this, of course, is the main texture. So this is the texture that we're going to use. You can see here that in this case, it's a spark texture, and here, the particle, of course, has the spark texture. This is being colored by the particle. We have tiling, so I can make a tile, for example. Let me disable the auto override for a second. And you can see now that the sparks are kind of doubling up on each other. We don't want that for this particular effect though. Then we have the main texture channel. Why is this relevant? Well, when you're optimizing video games, it's usually very common for you to pack your textures, like this one. So this texture, for example, it's a tack texture, and you can see that it looks kind of funky. But if I go here and I select only to see the red channel, you can see that the red channel only holds this middle part of information. The green channel only has this part of information, and the blue channel has the outer edges. So this means that on my shader, if I go back here to my little sparks, let's change the texture to be this new texture here. And now you can see that instead of overlaying the sparks, it's overlaying that texture that we were using. So what I'm gonna do, So what I'm gonna do is that here on the main texture channel settings, you see that currently I have 1 on everything. So what this means is that it is going to use all of the data from this texture, the red, the green, and the blue. The red, green, and blue channel are represented by this X, Y, and Z, and this is a common theme alongside the shader. You're gonna see this a lot. If I exclude the red channel, represented by the X, you can see that the middle core of our particle is gone. You can see here, it's on, now it's off. And I can do the same for all of these. Well, here the blue channel is not really showing up because it's very non-intense, but you can kind of tell how this works. Let's go back to our spark though. So now that we know how that works, we also know that this applies for the alpha channel. So in this case, the alpha channel is represented by the W. But if I wanted to use the red channel as the alpha channel, I would simply put a 1 here on the X value. In this case, since this texture only has data on the alpha channel, the red channel is considered to be completely white, and therefore would just make the particle a square of whiteness. Then we have texture panning. So texture panning is how much the texture moves over lifetime. So you can see here that if I make it 1 on the X, it is going to move 1 unit alongside the x-axis, and if I do that on the y, I'm going to move 1 unit alongside the y-axis, and so on and so forth. Desaturate is especially relevant when your texture has colors into it. Let me give you an example. Let's put this heart here as our new texture. Let's also go into the particle and make sure that the particle is plain white, which means that it has no custom color whatsoever. So you can see that now we have a bunch of red, pinkish hearts. If I select desaturate, you can see that as I move the slider, the hearts get more and more desaturated until they're fully black and white. This is extremely powerful because let's say I want to make a heart VFX, but I don't want them to be pink, I want them to be blue, for example. Then I can use the same texture and desaturate it. Another powerful feature of our shader is the soft fade option. You can see here that I have this VFX. Let me play it for you. It's a pretty cool looking Zap VFX. So let's take a look at how it blends with the ground. You can see here that it has a layer of dark smoke, but this smoke is blending very nicely into the ground. You can't really tell where the smoke intersects the ground plane. The way we do this is exactly by leveraging the soft fade feature of the shader. So here we have our particles. Let me isolate them. So you can see here, these are the smoke particles that I was talking about. And they have something called Use Soft Particles right below the saturate. It's a checkbox. It also has a slider, Use Soft Fade Factor. So if I decrease the factor, you can see here that something changes, but it's not quite fully visible what's going on. But if I unlock the Use Soft Particles, it becomes really obvious because now you can tell where the particles hit the ground. And there's a very visible seam instead of a faded, smooth transition. So this is very powerful if you want some of your particles to blend with rolled elements seamlessly. Look at the difference once again. Off, on, off, on. It's a very nice level of polish that is sure to set your game apart. The next setting that we have here is alpha override. Sometimes you want to have one texture as your main texture, but a different texture on the alpha override, which means that you want to use the alpha from one texture and the color and information from another. Let's get some examples here. Here we have this fiery looking aura. Let's isolate this element right here. These are just some rings that go up and down. You can tell that as the main texture, we have one noise texture here, and this noise texture only has information on the red channel, which means that we only use this portion of the texture. But here on the alpha, if I turn it off, it becomes very clear that the alpha is actually fading our material. And the way it's doing that is that it's using this texture, but only the red channel of that texture in particular, which is this gradient, this wavy gradient that is black on the top and white on the bottom. Alpha override also has many of the other controls from the main texture, which means it can be tiled, offset, you can choose the channel of the texture, and you can also add some panning motion into it. Let me pause this here so we can see here. Well, the panning is not very visible here, but it is there. Now it is a lot more visible, but now it's just invisible. Finally, we get to the most complex and most important part of our shader, the detail noise. Pretty much any complex material that you want to build, you're going to want to use the detail noise. Let's take a look at how it works. The detail noise has a texture input. In this case, we're using the same texture from the main texture. This texture has styling and offset like any other field, and you can also choose which channel you want for different effects. So the very first thing we have here is spanning. So we can see here that in this particular case, this texture is spanning alongside the y-axis. But now you can also tell that this has distortion information. So the distortion channel is a little bit of the red channel and a little bit of the blue channel. So pretty much a mix between this and this. You can also see here that we have distortion intensity. Pay close attention to the material as I increase or decrease the distortion intensity. See how different that looks? So now we know what the distortion is doing to this texture. Then we have the multiply channel and also the multiply desaturation. If you don't desaturate, you can see that it actually multiplies a little bit of the color in. So in this case, since our multiply channel is mostly the blue channel, it is putting some blue shades into our material. We don't want to do that, so we raise up the desaturation of the multiplication. The multiply channel, as you would imply, simply multiplies the texture. Here's the material without the multiplication, and here's the material with the multiplication. You can see that it breaks up the shape a little bit. And finally, we have additiveness. Additiveness, as the name implies, just adds color back in from the detail channel. I can make this the green channel, I can make this the blue channel, or, like it was before, I can make it the red channel. Finally, we also have the dissolve channel, but the dissolve channel is better explained by our first example. Here we have our fiery breath from before. Let's take a look here at the fire particles. So you can see that they spawn in, but they don't just fade away. They kind of get eaten away. The reason why they do this, it's because they're being actually dissolved by a texture. This is the texture in question. This is a fiery noise that I have. And you can see here that the dissolve channel is set to 1 on the x-axis, which is the red channel. This texture in particular is just black and white, so it doesn't matter. Now, on the custom data, we can see here that we have a couple of fields. I'm going to teach you guys how to put custom data into your particles. So the way you would do this is that you would go for your particle system, you go into the renderer tab, and then you're going to check this box here, custom vertex streams. You're going to hit that. And then finally, what you're going to do is that you're going to come over here on this little plus sign. You're going to do custom, and you're going to do custom 1 X, Y, Z, W. And you're going to hit that. Now, above the renderer tab, we have the custom data tab. You're going to set to vector, and you're going to get 4 fields. These are not going to be named accordingly, but I named them accordingly just so we understand a little bit better. But these are going to be named X, Y, Z, and W. Let's take a look here at intensity. Intensity, as the name implies, just adds more intensity to our particles. So these are currently set to be random between 0 and 4. But as you can see here, I can make it something ridiculous like 1,000, and our particles are going to reflect that. Let's go back to the default values though. Finally, we have erosion. In this case in particular, I'm using a pretty complex curve. But the way erosion works, let me go into a constant here, is that it goes from 1 to 2. So if I put this at 1, you can see here that we just have the particles with nothing happening. But as I increase it, the particles get gradually eaten away until they disappear. And they disappear at 2. Knowing this means we can turn this into a curve or random between 2 curves. And now, as time goes on, our particles are going to increasingly go closer and closer to the value of 2. Thus, they're going to increasingly get eaten away. We're going to come back to the U and V offset in a moment. Another trick that this particle in specific is using color ramping. Let me disable it so you guys can see what it looks like. This is how the particle looks like without color ramping. Color ramping is essentially a way of mapping a gradient of colors to your textures. This is especially useful if you want to achieve a very complex color schemes that blends between multiple colors. So for example, I can make my fire particles have a blue core. This is something that you could not achieve without shader help. You also have this slider that essentially dictates how much of the colors are going to be blended in based on the values of your shader. Finally, we also have Fresnel. Fresnel is really just Fresnel. There's no secret tricks to this. Of course, you're not going to be able to really understand what Fresnel is doing there, since these are not 3D models, but it's just default Fresnel, so I'm not going to spend too much time explaining it. Finally, we have the Use UV Offset. Let me get one VFX that makes use of this effect. So here we have a VFX that uses the UV offset from that checkbox. So let me show you here one of the noises that we have in this effect, this one. So this is particularly useful for solar coasters. If you don't know what a solar coaster is, and if you want to learn more about solar coasters, I'm going to have a video on the link in the description below teaching you what a solar coaster is. It's also a tutorial from Piloto Studio. Let's take a look at the material here. The way this material works is that it has the Use UV's offset, and everything else just has settings like we have been setting up so far. Very simple stuff, just some distortion, so on and so forth. But here are the custom data. You can see that we have some data on the V offset. Essentially, the way this works is that we can control the movement of the textures based on the custom data. Let me show you here that if I make this into a constant, I am able to move the noise back and forth by manipulating the V offset. So you can see here that as I move this variable around, my noise goes back and forth. And the reason why, it's because we have a 3D model, and this 3D model has the UVs mapped on the vertical coordinates. And you can see here that this is how we're able to fine-tune the timing of this sneeze-like effect that's going on here. You can see here that it's a very complex VFX with a bunch of models. This one also uses the same technique. So this adds this layer of complexity. Alrighty folks, so that is about it for all of the features in the Piloto Studio Shader. In the future, we'll be making a lot more tutorials which are all going to use these shaders and leverage their powers. So once again, you get it for absolutely free here on the Unity Asset Store. It works on all Unity versions and all rendering pipelines. So thank you so much for the attention and your time, and I'll catch you guys later.